The sound alone could split a truck stop parking lot into armed camps. On one side, the unmistakable two-stroke scream of a Detroit diesel 8V71, that supercharger whine building into a mechanical howl that announced its presence 3 miles before arrival. On the other, the authoritative four-stroke rumble of a Cummins NTC 400 big cam, shaking the ground with low-frequency torque that you felt in your chest before you heard it with your ears. Two completely different philosophies about diesel power, both dominating American highways during the golden age of trucking. Detroit Diesel's Series 70 represented revolutionary thinking, a two-stroke diesel that revved like a gasoline engine and delivered power with race car urgency. The Cummins NTC 400 embodied conventional wisdom perfected, a massive inline-six that generated locomotive torque and promised to outlast the truck it powered. The 1970s and 1980s witnessed these titans battle for the soul of American trucking. Fleet managers calculated fuel costs, while owner-operators debated reliability at every truck stop counter. Regional preferences emerged, brand loyalties hardened, and the choice between Detroit Scream and Cummins Rumble became as personal as Chevy versus Ford. But which engine actually won? The answer reveals an uncomfortable truth about American performance culture. Sometimes the most exciting choice isn't the smartest one, and sometimes efficiency matters more than the sound of freedom. Historical context and development. The story begins in vastly different places. Detroit Diesel's Series 70 emerged from General Motors' 1938 revelation that two-stroke diesels could work outside laboratories. While the rest of the diesel world remained committed to four-stroke architecture, GM engineers recognized that eliminating half the mechanical complexity meant fewer parts to fail, less weight to haul, and twice the power strokes per revolution. The original Series 71, named for its 71 cubic inches per cylinder, started life powering military vehicles, construction equipment, and Great Lakes cargo ships. The genius lay in uniflow scavenging. Intake ports at the cylinder bottom opened when the piston descended, allowing a belt-driven roots blower to force fresh air through the cylinder, while exhaust valves at the top expelled spent gases. Simple, elegant, brutal. By the 1960s, the 8V71 configuration, 8 cylinders in a V arrangement, 568 cubic inches total, had conquered the highway truck market, with power ratings climbing from 238 to 318 horsepower. Cummins Engine Company watched Detroit's dominance with growing frustration. Founded in 1919 by Clessie Cummins, the Indiana manufacturer had built its reputation on durability and conventional four-stroke engineering. Their answer arrived in the mid-1970s with the NTC series, New Technology Cummins. The NTC 400 Big Cam represented Cummins' declaration of war: 855 cubic inches of inline-six displacement, 400-plus horsepower, and over 1,450 pound-feet of torque that arrived at tractor-pulling RPM. The battle lines were drawn. Revolutionary simplicity versus conventional superiority. High revving power versus low RPM torque. GM's corporate might versus independent Cummins determination. The Golden Age. The 1970s belonged to Detroit Diesel in ways that statistics alone couldn't capture. That 8V71 scream became the soundtrack of American commerce, echoing through mountain passes and across desert highways. Truckers didn't just drive Detroits, they performed them, winding those screaming V8s to 2,400 RPM while rowing through 13 or 15 gears, the supercharger whine building like an air raid siren announcing their approach. Peak horsepower numbers told only part of the story. A naturally aspirated 8V71 delivered 318 horses, but the power curve was flat and accessible, living between 1,800 and 2,200 RPM where drivers actually worked. The narrow power band demanded constant shifting, but veteran drivers mastered the rhythm, keeping those two-stroke mills singing in their sweet spot. Fuel economy was abysmal, 4 to 6 miles per gallon when pushed, but in an era when diesel cost 40 cents per gallon, nobody cared enough to switch. The applications list read like a who's who of American trucking royalty. Kenworth W900s, Peterbilt 359s, Freightliner Powerliner COEs, and White Road Boss conventionals. Walk through any truck stop parking lot in 1975, and 6 out of 10 big rigs rumbled with Detroit power. The sound alone sold trucks. Marketing departments didn't need clever slogans when potential buyers could hear the difference. But by the late 1970s, a rumbling challenger was claiming territory. The Cummins NTC 400 Big Cam arrived with a completely different value proposition: fuel economy, longevity, and torque that could pull stumps. Owner-operators, independent truckers who owned their equipment and calculated every operating cost, started doing math that fleet managers had ignored. Technical brilliance. Beneath their competing philosophies lay fundamentally opposed engineering realities. The Detroit Diesel 8 Vi-71 was mechanical poetry written in two-stroke mathematics. Its 4.25-inch bore and 5.0-inch stroke created 568 cubic inches across 8 cylinders arranged in a 90-degree V configuration. But the magic happened in what the engine didn't have. No intake valves, no complex 4-stroke timing, no wasted rotation gathering fresh air. The Uniflow scavenging system was pure genius. As the piston descended past the intake ports at cylinder mid-stroke, the belt-driven Roots blower, spinning at 1.28 times crankshaft speed, forced fresh air through the cylinder at 5 to 7 psi. This constant positive pressure purged exhaust gases through 4 overhead exhaust valves while simultaneously filling the cylinder for the next combustion event. Every crankshaft revolution produced a power stroke. Every single revolution. The result was power density that 4-stroke engines couldn't match. The 8V71 produced 318 horsepower from 568 cubic inches, 0.56 horsepower per cubic inch, remarkable for a naturally aspirated diesel. The engine screamed to 2,400 RPM redlines, unthinkable for conventional diesel architecture. Maintenance was beautifully simple. Unit injectors for each cylinder, mechanical governor control, and blower drive belts that anyone could replace with basic tools. The inevitable compromise was thermal efficiency. 2-stroke diesels consumed oil by design. The blower pressure forced some combustion gases past the rings into the crankcase, requiring positive crankcase ventilation that burned roughly a gallon of oil every 500 miles. The single power stroke per revolution meant less time for complete combustion, resulting in black smoke under load and fuel economy that made accountants weep. Challenges rise. The October 1973 oil embargo detonated beneath Detroit diesel like a shaped charge aimed at every weakness in 2-stroke architecture. Suddenly, 4 to 6 miles per gallon wasn't charming character. It was business suicide. Diesel fuel prices tripled within months, and owner-operators who'd ignored fuel economy started calculating route profitability with brutal honesty. The 8V71's thirst became a liability that no amount of supercharger wine could justify. Environmental regulations delivered the follow-up punch. The Clean Air Act amendments targeted diesel particulate emissions, and 2-stroke engines were fundamentally difficult to clean. With only 1 stroke dedicated to combustion and exhaust, Detroit's engineers had no time to optimize burn efficiency or implement exhaust gas recirculation. Black smoke under load, the classic rolling coal that drivers once considered normal, became regulatory violations carrying serious fines. The oil consumption issue transformed from quirk to crisis. That gallon of oil burned every 500 miles meant constant refilling, but more importantly, it meant hydrocarbon emissions that EPA testing couldn't ignore. Detroit attempted Band-Aid solutions, improved ring designs, better blower sealing, modified port timing. Nothing fundamentally solved the problem that two-stroke architecture created by design. Reliability problems emerged at sustained highway speeds. The 8V71 had evolved from industrial and marine applications where duty cycles included rest periods. Over-the-road trucking meant 14-hour days at 65 miles per hour, the engine screaming at 2,100 revolutions per minute for hours. Crankshaft failures started appearing. Main bearing wear accelerated. The same lightweight simplicity that made the engine powerful couldn't handle sustained highway abuse. The PT fuel system's sophistication became a liability in the field. Contaminated fuel caused stuck check valves. The gear-driven fuel pump's close tolerances meant catastrophic failures if maintenance intervals stretched. Detroit's crude unit injectors could be swapped roadside with basic tools. Cummins PT injectors required specialized timing equipment. The transition. Detroit Diesel's admission of defeat arrived quietly in 1987, wrapped in press releases celebrating innovation. The Series 64-stroke inline-six represented everything the company had argued against for 50 years. Conventional architecture, four-stroke cycle, electronic fuel injection. The same engineers who'd championed two-stroke simplicity now praised four-stroke efficiency. The same marketing department that sold supercharger wine now emphasized fuel economy and emissions compliance. The 8V71 didn't die immediately. Production continued for marine and industrial applications where two-stroke advantages still mattered. Instant power response, compact packaging, and simplified maintenance in accessible installations. But for highway trucking, the last 8V71s rolled off assembly lines in the early 1990s, destined for niche applications and stubborn owner-operators who refused to accept reality. The ultimate irony twisted deeper. Detroit's Series 64-stroke became Cummins' most dangerous competitor, eventually capturing market share that the 8V71 could never reclaim. GM's diesel division learned the lesson Cummins had known all along. Efficiency beats excitement when fuel costs real money. The N14 engine family arrived in 1988 as the NTC's successor, carrying forward the 855 cubic inch displacement and big cam philosophy while adding electronic controls and improved emissions compliance. The transition was so seamless that many drivers didn't realize they'd switched engine generations. The fundamental recipe remained unchanged: massive displacement, low RPM torque, and engineering that prioritized longevity over excitement. By 1995, the market verdict was absolute. Detroit's two-stroke highway presence had evaporated. Cummins held 45% of the heavy-duty truck market, with Caterpillar and Detroit's new Series 60 splitting most of the remainder. The boring choice had won. The exciting choice became museum pieces and marine applications. Legacy and modern impact. Today, the 8V71 Detroit diesel exists in a strange space between mechanical relic and cultural icon. YouTube videos of vintage trucks screaming through gears accumulate millions of views, comments sections filled with middle-aged men sharing memories of their first drives behind Detroit Power. Vintage truck shows reserve premium parking for anything wearing the distinctive valve covers, and the sound alone draws crowds that modern turbocharged whisper-quiet diesels could never attract. The collector market reflects this romantic reverence. Properly rebuilt 8V71s command $15,000 to $25,000, with premium pricing for low-hour marine pullouts that avoided highway abuse. Parts availability remains surprisingly strong thanks to continued marine and industrial demand. You can still order genuine Detroit diesel components from authorized distributors, though prices reflect their specialty status. The engine's loudest legacy echoes through online forums and Facebook groups where older truckers wage comment section warfare, defending Detroit's honor against fuel economy criticism. "You young guys don't understand what you missed," they write, sharing stories of mountain passes conquered and state troopers outrun. The 8V71 screaming defiance against physics and speed limits. The mythology has calcified. Two-stroke Detroits weren't just engines. They were the last remnants of trucking freedom before regulations, and electronic nannies ruined everything. Rebuilt NTC 400 sell for $8,000 to $15,000, lower than comparable Detroits despite superior longevity. The market gap reveals the emotional premium buyers pay for sound and character. Owner-operators seeking pre-electronic power plants for new-build vintage trucks preferentially choose big cams, valuing reliability over nostalgia. You can't hear a Cummins 3 miles away, but you also won't be rebuilding it at 400,000 miles. So which engine really won? The one that made truckers smile every time they fired it up, or the one that actually made it to 1,000,000 miles? The screaming two-stroke that defined an era, or the rumbling four-stroke that proved efficiency beats excitement? Drop your thoughts below and subscribe for more diesel history, because sometimes the engine that sounds best isn't the one that goes the distance.